Hi everyone, I'm Terry Schussler and I'm the Senior Director of Spatial Computing for Deutsche Telekom. Today I'm going to talk about how we're unleashing the power of XR using 5G and edge compute technology advancements. So today we don't really have the holy grail XR device. Most people experience augmented reality using their smartphones. The reason for this is because most of the devices that are available today are too bulky, too heavy, or don't provide enough of an immersive experience, or they're actually just too expensive. And one of the things that I want to talk about today is how we can get to this better state with the devices through the benefits of 5G and edge compute. So most people experience augmented reality using their mobile phones. In fact, you might think of some of these folks as sort of walking zombies and the mobile zombie apocalypse of people prior to COVID walking around in the streets of a city looking only at their phone and not engaging with the real world. And this is a particular problem because the field of view that you have with your smartphone's camera point of view is only about 5% of what you would see normally with your eyes. So you're basically doing the equivalent of taking a toilet paper roll and sticking it up to your eye and trying to look at everything in the real world through a tiny little funnel. And so this is a problem, and it creates a issue with human safety in the real world that we want to address. So when we bring head-worn devices that can provide an immersive augmented reality experience to users, we are able to increase the safety of people while they're engaging in the real world and also benefiting from the information display of augmented reality. So in order for us to obtain these form factors that we want, these lightweight, less expensive, less bulky devices, we need to reduce the battery drain on the device. We need to reduce the weight by also offloading the battery itself and taking some of the functionality of the devices and taking it physically off of the device and putting it elsewhere. And so to do this, we have to take the advantage of a number of different advancements, including, for example, the advancements with the chipsets that are available for XR devices, such as the Qualcomm XR2 chipset, which is significantly more efficient, for example, with battery in terms of camera processing, where it can process up to 7 camera inputs simultaneously at 30 times the reduced battery drain of prior chipsets. We also get the benefit of advancements with new optics technology, where we're looking to get lighter weight, waveguide, or other optics platforms incorporated into a head-worn device that can feel like a pair of glasses. Something like today's Nreal Light getting lighter and smaller through these advancements. But also very important for all of this is the improvement in new sensor technology. A good example of this would be the LiDAR sensors that are now available in the iPhone 12 series. And I think, very importantly, 5G connectivity and edge compute offload. So let's talk a little bit about how those two come to play to improve the power of XR for users. Now, what we're moving towards is enabling lightweight, mobilely useful, tethered XR devices. Tethered in the sense that the head-worn device is actually connected to a mobile phone to get either battery, compute, or connectivity to the internet. And we're seeing the advancement of new devices that provide a mobile virtual reality experience coming to the table from a variety of different vendors in 2021, which utilize new optics platforms, pancake lenses, to allow the user to have a much more portable physical device that they can use to enjoy virtual reality content anywhere. These devices, again, plug into a mobile phone and then use the connectivity of the mobile phone and the bandwidth of 5G to enable the virtual reality content to be live streamed from the internet. Now, a lot of people think of 5G as really just about bandwidth, and it's much more than that. There's a combination of values that 5G brings to the table besides increased bandwidth that enables us to have this bridge between the real world and the digital world in a very important and reliable way. So let's take a little look at some of the key characteristics. So one of the most important things, of course, is that if we're taking some of our compute function and we're moving it from the device to the internet, the connectivity speed, the amount of time it takes for data to go from your device, your phone, to the network and get processed and come back needs to be very short. If it takes too much time, then the information will come in later than we want it for rendering purposes. And this is particularly important sensitivity for virtual reality, where we need at least 60 to 72 frames per second minimum, and ideally more around 90 to avoid having people be nauseous while they're using virtual reality content. But for augmented reality experiences, we need a low latency connection to the network. And so this is one of the big value propositions that we get from 5G radio, is a much reduced latency. The second, of course, is we've talked about data rates. So it's not just about the peak data rates, but it's also about the reliability of the data rate. Knowing that I can consistently get 100 megabits per second connectivity through a mobile connection to the network means that I can start as a developer and content producer, rely on this availability of bandwidth to create a consistently higher quality experience. And I can start to lean into utilizing network rendering to deliver virtual reality content. I can lean into using multiplayer synchronization mechanisms for a real-time augmented reality game with a group of people who are playing in the real world. And the other thing that's important, and it will become more important after we get through COVID, is the ability for us to have high density usage where we can serve more people in the same physical space with a consistent, reliable connection. And this is important, of course, in dense city locations, but also in venues like a stadium, where eventually we'll go back to having a lot of people in one place, and this will be a very valuable proposition. But also, it's important to consider the point I made earlier about reliability, because reliability is super important here. If we know that we, for example, turn on our phone and we don't have to actually even look at signal bars, you can imagine how things would change in your mindset about whether or not you're going to be able to use your phone to perform a function, to connect to the network and access data and compute functionality. So, in many ways, for me, 5G is really about turning the world into a global hotspot and creating this super reliable indoor and out connection to the network, where I'll have a baseline of expectation as a user that I can lean into. And as a developer of content, I can lean into as well. So I can set a common denominator experience that's much higher level than what we're used to seeing in the past. So let's talk about, the delivery of 5G. So 5G, has been, a bit of a Tour de France, a bicycle race that, the lead is always changing. There's always somebody drafting somebody else. But we're kind of gotten past that phase with 5G deployment, and now it's really substantive, not just in Germany where Deutsche Telekom is headquartered, but also globally. The acceleration, the velocity that deployment of 5G radio has had, even just in the U.S., is really significant. And globally, right now, over 1 billion people have access to 5G radio connectivity. So it's significantly available already, and it will only accelerate over the next couple of years. So let's talk about edge compute for a moment. So today, when we connect to the network, we typically talk to a data center that's pretty far away from us to get the data that we have on our device to be processed, to have some computational work done, and the results returned. And this amount of time that it takes to transfer the data from the device to the local tower to the backbone can take easily up to 80 to 100 milliseconds on average. As we introduce the 5G edge cloud, we can take advantage of the combined lower latency of the connection to the radio network as I mentioned earlier, as little as just a millisecond or two, um, as well as reducing the latency from the node on the network to the compute function on the internet. And this is done by moving the actual data center of the edge compute infrastructure closer to the user to access the closest possible compute services to the user so that the amount of distance that the data has to travel is significantly reduced, thereby reducing latency on the network. And so this is a really key value proposition of edge compute. So we do this by actually building special edge compute data centers and geolocating them so that the average user in a particular geography, such as the country of Germany, is able to connect to that data center with a much lower average distance than it would be normally the average if you're connecting to a data center that is a typical cloud backhaul data center, which is going to, on average, be many hundreds of kilometers farther away. So this is a very important part of enabling XR use cases because this reduction in latency allows us to have a much more real-time experience, and more in particular, try to do things in under 20 milliseconds for a VR user so that we can allow the user to actually have their content rendered on the network instead of on the device. And we can respond quickly enough to lateral movements of the head and other interactions the user does to create that properly rendered experience. And so without edge compute, some of these XR experiences just simply can't be done with today's current infrastructure. So we have actually deployed or spun out a separate company called Mobile Edgex, which provides a software layer that can sit on top of all this hardware infrastructure and enable the developer with a very simple API to have their application intelligently be connected with the nearest piece of compute hardware that can provide the services the application needs. And so what Mobile Edgex's Edge Cloud does is it orchestrates the connection between the application and the edge compute infrastructure so that the user gets the services they need, and it's done in the most performant way possible. And so they do that by mapping out where everything is, figuring out where the user is, and then quickly orchestrating the connection and enabling of the access to the services that are needed for that particular application. So I highly recommend that you check out mobileedgex.com to learn more about the different types of use cases that edge compute can enable for XR applications. The use cases that we have for edge compute are very powerful. For example, I mentioned earlier the idea of synchronizing multiple players who are engaging in a real-time augmented reality game. We need to be able to track very quickly their positioning and be able to use the information from the phones, the user, and the glasses that they have to make sure that each player's position and actions are synchronized with all the other players. And so we've already demonstrated in the last couple of years a number of different multiplayer game applications that provide a very tightly synchronized experience using edge compute processing to maintain the synchronization between the players, and in doing so in a really performant way so that it feels the way it's supposed to. We're also leaning very much into utilizing edge compute functionality for rendering content on the network and delivering that to mobile phones and glasses. And so here we can take really complex compute tasks, rendering a scene with 100 million polygons or a billion points in a point cloud, cannot be done on a mobile phone or any AR or VR device today. But we can do it using higher end GPU rendering technology in an edge compute data center, and then we can stream that down to the user's glasses or phone from the network and create a rendered experience that's much higher quality than we could ever do normally. And so this is a very powerful use case that's getting a lot of exploration right now as some of the pain points for network-based or edge computer GPU-based services are now being addressed. There's a lot of advancements through work done by NVIDIA with their Cloud XR technology. And so we'll see a lot of improvements here to really accelerate the use of network-based rendering. Doing real-time stereoscopic rendering out of a game engine, for example, could be very, very powerful for delivering new use cases. We can't use augmented reality content without knowing where we are in the real world and having maps to localize ourselves against. And so we can actually take the edge compute infrastructure and we can offload the computation of spatial maps using still pictures and video content as a source and bring that to an edge compute infrastructure where it can be more performantly done and turned into a spatial map that can be then turned around and used by the client application in a real-time basis to create localization both indoors and out. And so we're seeing a lot of work done in this field by a number of different companies. Not all of them are the big players. Some of them are smaller or relatively smaller players. And so you're going to continue to see advancements in this area where we get to know more than just where the floor and the wall of the room is, but we can actually start to understand the detailed geometry of the space that we're in. And then we can start to recognize discrete objects and what they are, and we can actually classify all of the objects in a particular scene. So we can say there's a chair, there's a table, there's a plant. In fact, that particular plant is, a potato plant or whatever it is, and we have the ability to really understand more intelligently what's going on with the user's environment. And then we can start to augment the content that's displayed in that environment based on our knowledge of it. So the semantic scene graph, to me, is a really important leverage point that we'll have for XR use cases moving forward. And I also have to do a shout out for the OpenAI Cloud Foundation, which I've been involved in since it was founded, as they're doing a lot of real great work to figure out ways to enable a developer community to have a consistent way to access all of these different spatial mapping platforms and enable development across different ecosystems of spatial mapping based applications or AR cloud based applications. So highly recommend you check out openarcloud.org. So in summary, to just kind of wrap it up, the benefits of 5G and edge compute are that by using these, we can enable the physical form factor goals of the XR devices, because we can start to push the computational load completely off not only the device, but even off the phone and onto the internet. And we can allow for really large data sets to be used to enable much broader range of applications, whether it's large spatial maps or really complex polygon models, or even just computer vision models, machine learning models, which are fairly large, and have those deployed on edge rather than trying to download everything to the device. We can allow the user to have a very low latency experience, what I call the immersive internet or tactile internet, because the latency that we are able to get to is so low that we're able to create this sort of real-time experience where, if we were in a collaboration platform with our avatars reaching out to give each other a high five, like I am in AR right now, that we would actually be able to do that in a very synchronized way and even have haptic feedback and a controller or a glove that we're wearing. So we could have that haptic high five experience in AR and have that sense of digital presence that we so dearly need today. Combining 5G and edge compute allows us to extend the power of smartphones, the value of smartphones for XR applications, because we're decoupling the dependency of the display and the smaller field of view of the smartphone and allowing the user to have a heads-up experience where they're looking at things in the real world while they're benefiting from the content of the augmented reality or mixed reality applications they're running. The key thing that I think it's really all about ultimately is sort of tied to the motto that we have, which is life is for sharing. And that is that users can increase the communal interaction while they're benefiting from XR. So it's not an either or proposition. I'm either heads down looking at my phone and ignoring the real world, or I'm heads up and I'm looking at you and engaging with the real world, but I don't get the benefits of the technology and the data. So we believe that with 5G and edge compute, we can bring those things together to create an immersive experience for all users. Thank you.